video is made to showcase some of the functionality of cleanX. I just imported the latest version of cleanX from my own machine. And now I'll import the modules, dataset processing, DICOM processing, and image processing. cleanX allows you to read DICOM with either simple IPK or PyDICOM. The preferred module is in fact PyDICOM, and I have it, so I'll be using it. I have already put a DICOM example folder on my machine, and now I will read the data from it. So this metadata was associated with the DICOM and the DICOM example folder on my machine. But of course, I also want the images. And I can put them into an output folder, as shown above. Once I have my images and data set, if I'm preparing for machine learning, I will want to examine them to make sure that the images and data sets are clean. I can create a report on the data set by using ML setup. This report below is made for Jupyter Notebook in terms of formatting. It will show duplicates in my test and train set. It appears there are no duplicates in my train set, but one in my test set. This is a data set that I have made explicitly, specifically to showcase the possibilities for using cleanX. I used almost identical data sets for training and testing to show that it would catch ones that were repeated, which I have called leakage. If you have images in your train and test data set, which are the same, you have what I call label leakage, and you'll want to catch this. In this case, I've used two data sets that were almost identical, so almost every line is the same, and they will show up as leakage. You may also want to look at sensitive categories in your data in terms of the metadata. In truth, many chest X-ray data sets feature more males than females. As data sets get smaller, they may not include any normal females. And this is a problem because the algorithm may then read signs of female chest X-ray, such as breast, as a signal for pathology, when in fact this was never the intended outcome. So whether your sensitive category is gender or the geography of where the image was taken, if it exists in the metadata, you can then sort out and count values in terms of normal and any pathology. In this case, the pathology was pneumonia, and we see we have, if not perfect, a decent spread of men and women who had pneumonia positive X-rays, and men and women who had normal or not pathological X-rays. And of course, when I say pneumonia positive X-rays, I really mean diagnosis of pneumonia, which the X-ray gave some indication of. Pneumonia is, of course, a clinical diagnosis, and consolidation in and of itself is not always pneumonia. From a technical standpoint, you may want to know what is in some of your columns, how many rows there are, how many nulls there are, etc. And it can come out of the report as well. So using ML setup, you can examine your tabular data. Here, it was formatted for a Jupyter Notebook, but you can also simply format the same information in plain text if you want to use a command line interface or another type of interface, or even send yourself an email about your data. The images also need a closer look when you are creating a quality machine learning algorithm. it is absolutely essential to crop away black frames around the image, but you may also want to normalize your images or perform other steps that will pre-process them. So these steps can be performed with the pipeline. Here I have an image directory and an output directory. Here I will show the curated set of images that I've decided should go in my image directory. And of course, on purpose, I have put in an image that clearly needs to be cropped and some very light images that might do with a little bit of histogram adjustment. So my pipeline step here will be to acquire, crop, and histogram normalize and save the images. And then I'm going to take a look at them. This notebook is working with a very tiny group of DICOM, a pretty small data set of tabular data, and a very small group of images. However, these were picked so that the notebook would execute fairly rapidly, and some of the functionality of cleanX could be made obvious with very little computing power and very little time. So here we see my image here got cropped, and lo and behold, the histogram normalizing seems to have darkened up my graph images, as well as a couple other images. There's also a kind of normalizing in the pipeline that does not work on histograms and simply shifts all the values between 0 and 255. There are many, many other functions in the code for cleanX, functions that allow many different types of augmentation and synthetic augmented data creation. However, this is just a portion of what is available with cleanX. I hope you will enjoy